everyone, this is lesson 15, derivative rules. Okay, so last time we learned average rate of change, right? So in general, we are using average rate of change for how quantity changes over time. Okay, then this is the formula. I said think slope, right? Okay, now we have derivatives. So we introduced this word last time. So derivative. And then we had average rate of change, average speed last time. And then we take the limit, that's the derivative, right? So we read f prime of x. Then we say that if the limit exists, and then we have f prime of c exists, then f is differentiable at c, right? Okay, today we learned the rules of derivative of functions. Okay, so let's do this one. So before we do that, derivative, same as a differentiable at c, and derivative of a function. So we denote like f prime of x, and the instant rate of change is the same, right? And then slope of a line tangent to the graph, f of x at x. Okay, so since this one comes from slope, right? This is from the slope. Yeah, this is a slope, right? So we say that slope of the line tangent means the line touch the tangent line tangent. So the touch the point. Line tangent means the line which is touched point. A point. How about that? So if we have the graph, then this is touch the point or touch the point. Point. Okay, how about that? Touch the point. Those are line tangent. So basically, the straight line of the slope, right? Slope of the straight line. Okay, so we have the power law when you derivative, because this is too much work. It's a lot of steps, right? So we want to derivative. Why we want to derivative? Because we want to know about instantaneous rate of change and then slope of the line tangent to the graph of the function, right? That's why we want to derivative. But then this is a lot of work and a lot of steps and takes a lot of time, right? Okay, then we have an easier way because we tend to go to easy way all the time, right? Convenient, right? Yeah. Okay, so we have a power law. So what's the power law says? Here, f prime of x. Then if we have a power, like a polynomial, right? The power, then we drop the power, then reduce it by 1 for the power, right? Okay, let's do it. We do derivative, yeah? So we have the first one. We drop the power. So let's denote y prime. That is, we drop the power 1/4 x, and then we reduce by 1, right? So reduce by 1, in that case, 4/4. So 1/4 minus 4/4. That will be 1/4 x to the 1 minus 4, which is negative 3/4. Okay, now we have to think about this. We had a to the negative m. We did the last time, right? So that will be 1/a to the m, right? Okay, but then we have the root. This is a root, right? And then numerator will be the power, right? So we can express this one 1/4, 1/x to the 3/4. So this will be root, we know, and then this will be power. So how do we write? We write 1/4, 1/4 root, x to the 3rd power. Make sense? Okay, so let's do this one. F prime of x. We want the derivative of the function. Then we drop the power, -2, and reduce it by 1. It's -3 for the power. Okay, negative power, -2, and then we can say that x to the 3rd power, right? Okay, now we have a y equal to x, y prime of. Okay, look, we pretend there is 1 for the power, and we drop the power, reduce by 1. Then 1 minus 1, which is 0. Okay, what's the x to the 0 power? It's 1, right? So we get y prime equal to 1. So let's remember this one. You don't have to memorize, but let's remember, right? Because if we have x, then if we do derivative, then we get 1. So that we don't have to do this work, okay? All right, now g prime of x, we have 1/3, drop the power and reduce by 1. In that case, 1 is 3/3. So we have 1/3, x to the -2/3. Okay, x to the negative power, we can rewrite it 1/x to the 2/3. Okay, the denominator will be root. And then the numerator will be the power, right? So this is the power. So we will get 1/3, 1/, cube root, and x squared, right? Okay, now we have p, so p prime equal to, drop the power, 2/3, q, and then we reduce by 1 for the power. So 2/3 minus 3/3, that's the 1 in the case. So it will be 2/3 q to the -1/3. So we can express this one, 2/3, 1/q to the 1/3. And that will be 2/3, 1 cube root, q to the first power. But we don't normally write 1, right? So that is the one. Okay. C prime of t? We don't see the power, right? But then square root, what do you get? T to the 1/2 power, right? So we drop the power t to the -1 for the reduced power. So in that case, 1/2 minus 2/2. So that will be 1/2 t to the -1/2. Okay, then there's 1/2, 1 over t to the 1/2, which is 1/2, 1 over square root of t. Okay, now f prime of x. There is no power, so we can express this one. Look, x to the -1/2, right? So maybe I'm gonna make a note here. If we have a to the -m, then we have putting down here, right? So I explained to you why last time, right? So this one, if we have 1 over a to the -m, then since we have a -m, we bring up, so it will be a to the m power. I explained to you why, right? Okay, so well, a to the m power means a to the m power over 1, right? Same as. Okay, now there will be, look, this is a little bit different, right? So if we have 1 over a to the, how about maybe this m, yeah, m. Okay, then we will rewrite a to the -m. It's the same, right? Isn't it? This is the same? Yes? This is the same as, yeah? So this is the one, same as. Okay, now we have x to the -1/2 powers. Then we drop the power, -1/2, and reduce by 1. In that case, it's 2/2, so -1/2 minus 2/2. So we have -1/2 x to the -3/2. Negative power, we can express 1 over x, and then square, and then to the 3rd power, right? Root and power. Okay, now we want to find the f prime of 1 and f prime of 7. So then we have to find out what's the derivative of the function. Drop the power, reduce by 1. Then that's 1. So we don't normally write down 1 for the power, right? Like 1 times x. We normally don't write down 1 times x, just x. Okay, now what's the f prime of 1? So 2 times 1 equal to 2. F prime of 7 equal to 2 times 7 equal to 14. Okay, so in that case, x squared, which is, looks like that, right? For your reference. So x squared. Now, f prime of 1 means 1 is here. Then we want to know about the slope, line of tangent, right? So in that case, the slope equal to 2. And when x equal to 7, 7 it's about here. Let's say that. Then the line tangent like this. So m equal to 14. Make sense? Okay, now coefficient rule. So we had earlier the power rule, right? So power rule. So we have f prime of x equal to n x to the n minus 1, right? If the function has this form, and for anything, whether positive, negative, 0, right? All right, now quotient rule. If we have the function, they denote c as a coefficient, and then this is a function, right? Then we keep the coefficient and then derivative of the term or the function, right? Okay, let's do that. F prime of x by the quotient rule. We keep the quotient, and then x to the fifth power, we want to derivative x to the fifth power. Then we drop the power, reduce by 1. So it's a 4. Okay, then we get 20 x to the fourth power, right? Okay, second one. G prime of t, we keep the coefficient, we drop the power, reduce by 1, t to the first power, right? Okay, that will be, we can simplify. 2 over 2 is the 1. We have a t. Okay, now we cannot say 5 over square root of q. All right, so we want to derivative p prime and 5. We need to convert to the power. So there will be q to the negative 1/2 power. Oh, we're not done yet, right? So sorry about that. So let's write down this way. Okay, now we keep the coefficient 5 and then drop the power by power rule and then reduce by 1 for the power. So 1 in that case is 2 over 2. So we will get negative 5 over 2 q to the negative 3 over 2. We have a negative power, so we can express this one. 1 over q to the 3 over 2, then negative 5 over 2, 1 over square root of q to the third power, right? Okay, now, constant rule. Constant rule. If we have a constant, that's the 0. Okay, y to the 2. So, y prime, constant itself. So think about constant rule, constant itself. Don't get confused with the coefficient, okay? Coefficient, we keep the coefficient. Constant by itself, number by itself, we said constant, right? Number by itself, we said constant, right? Then it's 0, 0. Okay, for your reference, y equal to 2, that's the horizontal line, y equal to 2. Okay, what's the line slope? Line slope? Slope of a line tangent? This is 0, flat, right? So that's why we get y prime equal to 0, derivative of the function, right? Okay, so constant term, f prime over x equal to 0. And constant function is 0. If we derivative, everything is 0. What a nice, right? Think about the slope. Okay, now some rules here. So we have sum of two polynomial, the function. We do derivative, the first term and second term respectively, right? Okay, difference rule is the same. We do derivative, first term, and the second term respectively, all right? Okay, let's do that. Y prime. Okay, then we want to derivative of first term, so let me denote this way. 3x plus derivative of second term. Later on, we don't need this step because we can do like that, right? Okay, so this means we do derivative respect derivative of the function respect x. Okay, so the first term, we have a coefficient, right? So coefficient is different with the constant. So there will be 3. And second term, okay, wait a minute. So x, right? X, we drop the power, that's times 1, reduced by 1, which is x to the 0 power, x to the 0 power, which is 1, right? So 3 times 1 times 1, which is a 3, right? Okay, so I said that earlier, right? We should remember y equal to x, y prime of, then that's 1, right? So we don't have to work the steps, right? Okay, now second term is the constant term, so it's 0, which is a 3, yeah? Okay, this one, f prime of x, since we have 4 terms, let's skip this one. I'll do later if you need. Okay, so first term, we want to derivative. We keep the coefficient because coefficient there are 4 times, and then we drop the power 3. And reduce by 1. So it's a 2 minus, keep the coefficient 2, and drop the power 2, and reduce by 1. So that's x, no space, and minus, it's a plus 5. Once again, 5x, we keep the coefficient. Yeah. Let me write down. Note. Derivative 3x equal to 3. And derivative 5x equal to 5. Yeah. Because of the reason. The derivative of x equal to 1, right? By using power. Okay. So we have third term. That's it, right? And then last term is 0. Okay. Then we calculate 12x squared minus 4x plus 5. Is okay? Constant is 0. Okay, let's move on. So P prime derivative with respect to Q, 1/3 Q to the third power plus derivative with respect to q, 2q to the second power minus derivative. Oh, we have to give it to the minus inside, yeah. And -3. Okay. So what do you get this one? We keep the coefficient, drop the power, and reduce by 1. Okay, let me write down reduce by 1 because I'm using color. Okay, so q to the second power, second term, keep the coefficient, drop the power, reduce by 1, so q to the first power, and then third term is 0. Okay, we can simplify, and we have a q squared plus a 4q, right? Okay, second, the next one. So u prime of x. Okay, we keep the coefficient first and then drop the power. X to the reduced by 1 is 3. And there's no coefficient, but we can drop the power by power rule. And then x to the -1 power. So that is, we need a space. Oh, okay, so 1/3 minus 3/3, right? Okay, so that's 20 x to the third power plus 1/3 x to the -2/3. Let's rewrite it. 1/3 1 over x to the 2/3. This will be 20 x to the third plus 1/3 1 over cube root x squared, right? Okay, next one. Y prime derivative with respect to x, 4x to the third, and plus derivative with respect to x, square root of x. Okay. We want the derivative first term, so we keep the coefficient and drop the power, reduce by 1. So we get x to the second power plus, okay, so this one, we have x to the 1/2 of power, right? So we drop the power, reduce by 1. So 1 over 2 minus 2 over 2. So there will be 12x to the second power plus 1/2 x to the -1/2. Okay, x to the -1/2 we can rewrite easily. 1 over square root of x, yeah? Okay, next one. P prime of x. We keep the coefficient and then drop the power, x to the -1. So fifth power. And then let's rewrite this one, right? Not x to the -2, right? So negative x to the -2. So we have drop the power, so negative and -2, x to the -1, so -3. There will be 30x to the fifth power plus 2 x to the -3, 30x to the fifth plus 2, 1 over Okay, let me rewrite it this way. 2 over, right? 2 over x to the third power. Is okay? All right, now, in addition to f prime of x, we read f prime of x, right? F prime of x. So we can express another way. So we have a dy over dx, means that we're looking at the y equation, and derivative respect to x. So omit a little bit, derivative of function respect to x, okay? No space. We knew y prime, I just introduced it, right? Y prime and d over dx, and then the function notation. That means with the derivative, the function respect to x. Yeah. So this sub x, y, and this sub x, f of x. We're not really using those kind of notation. So it depends on variable. We change that dy over dx, dt over dx, and so on, right? Okay. Now, let's do this one. Total personal income in the US from $4.9 trillion in 1990 to $15.3 trillion in 2015. This personal income I billions dollars, and from 1960 and projected to 2024 can be modeled. I over t is that, and t is the number of years after 1960. For 2020, find the models prediction for A, the total US personal income. Okay, so A, let's do it. So for 2020, so we make a 2020 minus 1960 because as t is the number of years after 1960, right? Okay, then this is a 60. And we want to find the total US personal income. So this is a personal income, I over T. Oops, try to crop. Okay, so let's substitute when t equal to 60. So I over 60, 6.12, 60 squared minus 49.7, 60 plus 620, right? So we get, let me do this one here. 19,670, and then billion dollars per year. 19,670 billion dollars per year. Okay, now second part, rate of change. Yeah, so Rate of change, usually they don't write down instantaneous rate of change, right? So rate of change means instantaneous rate of change. Instantaneous rate of change, okay? All right, second part, if we want to know about the instantaneous rate of change, then we want to derivative of I, right? So I prime of t, or we can express di over dt, right? So we're looking at the I equation and the derivative respect to t. All right, so what do you get? Oh, looking at this one, right? We keep the coefficient and drop the power, which is by 1. And then t minus 49.7. That's it, right? Because drop the power, it's 1, right? Like earlier, 3x, derivative of 3x, which is a 3, right? Just a coefficient. And then last term is 0, if we derivative, right? That's it. Yeah, we need to simplify. So it will be let me calculate. So I have it there. So it's a 12.24 t minus 49.7. Okay. Then what happened to the t equal to 60, right? So t equal to 60. Let me write down t equal to 60. So I prime of t equal to 60. We have 12.24 and 60 minus 49.7. Okay, then we get $684.7 billion per year. Okay, we can denote per year with a line, right? Okay, now see, interpret your answers to per B. Okay, so the total, the part B, C part, the total. So since we have a positive for second part, $684 billion per year, right? So we say that total US personal income is predicted to increase by approximately that money, $1 billion per year in 2020. Okay, so let me write down the total US personal income is predicted to increase by approximately $684.7 billion per year in 2020. Okay, so we have a marginal. Okay, we need to fill out the chart. So we know how to do it, right? So R over 1, 1500, X will be 1, minus 0.02, 1 squared, which is 1, right? Then we get 1499.98. So if we do the same process, second one is 2999.2. Third one out of 50, 74,950, 51, 76,044.7.98 out of 100, 149,800. And then 101, 151,295.98, 500, 745,000, 501, 74, 6, 746,479.98. Yeah. Okay. So we know how to calculate out of 2 minus out of 1, right? So out of 2, 2999.92 minus 1499.98. Then we have 1499.94. Okay. We know how to calculate. Let me just writing out the answer. And 101, 100, 1495.98, and then 1479.98. Okay, derivative. So let's derivative. Take the coefficient because we have only x. There's no dropping the power because power is the 1, right? So we have 1500 and keep the coefficient negative 0.02 and then drop the power, which is 2 and x, right? Reduced by 1. Okay. We get 1500 minus 0.04x, yeah? Okay, r of 1, r prime of 1, right? So 1500 minus 0.04 times 1, we get so we get this one 1499.96. Okay, now r prime over 50, then we know how to calculate. So it's 1,498. R prime of 100, 1,496. R prime of 500 is 1480. Yeah. Okay. Now, marginal revenue. Marginal revenue. What's the marginal revenue? I think we talked before, right? Okay, marginal revenue is an approximation or estimate of increase in revenue from sale of one additional unit. So if a company sell 50 and then they want to know about the one additional, so 51, then what's the marginal revenue by one additional unit? Yeah. Okay. Then how do you find marginal revenue? We make a revenue and then derivative of revenue, right? So we denote marginal revenue, marginal, the first letter M, marginal, and then revenue, first letter R, and then we have the line there. So we read Don't read. Just we read that on the bar, but just say marginal revenue. Don't read. Okay, so we have a R prime of X, right? Okay, marginal revenue, think about the revenue, and then we do derivative of revenue, okay? Then we can add one more, right? Why we want to derivative? Because we want to find instantaneous rate of change, right? And what else? We want to know about the slope of line tangent, right? At the point. Now, we want to find marginal revenue, right? Okay, now we have, oh, marginal cost again. So marginal cost, so we are using the function notation as C over X, right? Cost function, total cost. Okay, then we want to derivative, then we set the marginal cost. So we had just earlier marginal revenue, right? This one, think about the cost, and then we do derivative, then marginal cost. Okay, similar, the concept. Because the cost, this one also, they want to know about the production of one additional unit, right? Okay, so same as if they have, the company has a cost for 50 items, they want to know about the one additional one, 51st. Yeah, then they're using marginal cost. Okay, so here, just highlighting marginal cost. Okay, let's do this example. Almost done. I know this is a long, right? Okay, so we have the function, cost function. Then we want to know about C of 80 and 81. Okay, let's do it. C of 80 and 0.001 and 80 to the third power. And minus 0.3 and x to the second power and plus 2500. Okay, so I get 3652 C over 81. So let's using this one. Change it to 81. Oops. Eh. Did I copy? Wait a minute, one more time. There we go. Okay, so 81, change that. Ooh. Eighty-one, 81. So if we calculate this one, 3655.14. Okay, now what these numbers represent? It's they selling 80 blender, then Their cost is $3,652. And then they're selling 81 blender. Then they have $3,655.14, right? Okay, I'm not gonna write down because this is the obvious, right? Okay. Second part, by how much does it cost increase if an 81st blender is produced, right? Okay, now B. So that means we want to know about the C of 81 minus the C of 80. C of 81, which is 3,655.14 minus C of 80, which is 3,652. Okay, if we calculate, that will be $3.14. Okay, now C, find marginal cost function. How do we find marginal cost function? It's right there, right? Marginal cost. So we do derivative of the cost function, right? So marginal function, they using notation like that, and then C prime of X. Okay, let's read this one. We keep the coefficient and then drop the power and then reduce by 1 for the power. Drop the power and reduce by 1. So second power, right? Minus, keep the coefficient and then drop the power, reduce by 1, which is 1, right? And then third one, 32. And then last term is 0, right? Okay. Now, there will be 0.003 x to the second power minus, oh, missing something, huh? X, missing X. Because we drop the power, second power, so 2, reduced by 1. I mentioned that reduced by 1 here. 2 minus 1. Why didn't I put the X? Okay, so 0.3 times 2, which is 0.6x plus 32. Okay, now that's the marginal cost function. D as dog. I can be really good sounds of a dog. But it's too late now, right now. Okay, so what is the marginal cost at a production level of 80 blenders? Oh, unit. Okay. So C prime of 80. So 0.003, 80 squared minus 0.6, 80 plus 32. Then we get $3.20. This is dollars and per blender. This is a unit, right? Okay. Include the correct unit in your answer. Okay, this means, let me write down. Hold on 1 second. I need a space. So this means the marginal cost at production, the marginal cost at production level of 80 blenders is $3.20 per blender. This means when the factory is already producing 80 blender, the cost to produce one additional blender, right? That is the definition of marginal cost. So the 81st blender is $3.20. Okay? Yeah, this one we can say the A part. Interpretation about the definition of marginal cost. Okay, last question we have. Ta-da-da! Marginal profit. Okay, marginal profit. Every time marginal means the one additional one, right? So here, marginal profit, estimate increase of profit from sales of one additional unit. Okay, how do you find marginal profit? So we have a profit function with a derivative, right? Okay, so let's answer this one. We have a total revenue. So we're using first letter R and the R over X. It's a revenue function, right? 46X. Now, cost function, we're using first letter as C, cost function. Okay, find the P. P means profit, right? So means profit. Now, how did we find the profit function before? I can hear you. Okay, so we have a profit function equal to revenue function minus cost function, right? Okay, so we denote P of X, revenue 46X minus, be careful, it's a whole thing, right? We subtract whole thing. So we have 100 plus 30X plus 0.1X to the second power. There will be, excuse me, so 46X minus 100 minus 30X minus 0.1X squared. Okay, then we get many term is negative. Okay, let's make a negative 0.1X squared and then positive 16x and negative 100. That's the profit function. Then the first one we want to know about when x equal to 100, so p of 100 equal to negative 0.1. Make sure 100 squared plus 1600 minus 100. Okay, so we calculate and we get the 500. That's the profit. So they sell 100. What's the X for? They don't say anything about the X. Yeah, some items, then they get profit $5. Oh, no, $500. Okay, second part, marginal profit function. How do we find the marginal profit function? So we are denote this notation, marginal profit, right? Then we want to know about derivative of the profit function. Okay, so we keep the coefficient, drop the power, reduce by 1. Then that's 1. And 16. And then third one is 0, right? That's it, right? Oh, need to calculate. So negative 0.2x plus 16. Okay, C part, we want to find marginal profit when x equal to 100 and explain what it predicts. Okay, so C. P prime of P prime of 100, marginal profit. Okay, negative 0.1, no, 2, x 100 plus 16. So we get negative 4. Okay, so this means that when the production level is at 100 units, producing one more unit. The 101 step unit, one more addition, right? It's predicted to, since we have a negative, it's a decrease, right? We have a positive, then increase. The profit by $4. Okay, last one, D. So find P of 101 minus 100 and explain what this value represent. Okay, so P of 101, we need to find out. Let me change this one to 101. Copy. Okay, so 101. Oops. 101. Okay, then we get 495.990, same, right? We talk about the money. Keep the two decimal places. Okay, now we knew P of 100. Let me just copy and paste. Copy, paste. Okay, so P of 101 minus P of 100. That will be $495.90 minus 500, which is negative, right? So negative 10 cents. Yeah. So what this mean, right? So this means this means that producing the 101 set unit decrease decrease is it spell right? The profit by $4.10. Okay. Thank you for watching. Bye.